Hello friends, welcome back to my YouTube channel Soil and Agri IQ, where soil science and agricultural related topic made simple, easy, concept oriented and exam oriented. So I am Dr. Bhavani Prasad Mandal with you, working as an assistant professor cum junior scientist in Department of Soil Science, Bihar Agriculture University, Savor. And today we will going to discuss about problematic soils, because you all know we are now conducting the series on the problematic soils and their management. And in today's lecture, we will discuss about problematic soils, their concept and classifications. And in my earlier lecture, I have discussed about what is soil quality and what is soil health and how they affect crop production. And we all know that a good quality soil or a healthy soil produce bumper crop. They provide a good environment for good crop productions. Now, some questions arises in our mind. What are those questions? If we see what happens if a soil fails to perform all these specific functions, then you see, if the soil become too much saline, then what will be the effect on the absorption of the nutrients or the water? And if the soil become too much of acidic, then what will be the effect on the availability of the nutrients? Then you come, if hardpan develops in the soil, then what will be the effect on the root penetration or the root elongations? And if the microorganisms in the soil are getting died, then what will be its effect on the soil fertility? If really such conditions are going to happen in your soil, then these conditions soil pose major limitation to the crop productions. Okay, in that condition, soils are known as problem soils, or you can say these are problematic soils. Okay, so let's understand that understanding such type of problem is very much essential, because if you do not identify the problem, then how you can manage it? Now question is coming in your mind that what are problem soils? Let's understand the concept of problem soils. See, problem soils are those soils having one or more physical, chemical, biological, or maybe the nutritional constant maybe in the soil that restrict normal plant growth, and it ultimately reduce the crop productivity, or you can say the agricultural productivity. Okay, so these soil require special care or special management practices to promote or to sustain better crop productivity. Okay, so in a nutshell, we can say that problem soils cannot produce optimum crop yield until or unless you are not taking the optimum management practices to that type of soil. Okay, so now we'll understand why this is a major concern to our agricultural production, why we are discussing problem soil. So let's understand the importance. You all know that total geographical area in India is 328.8 million hectare. And the estimate by NAS 2010 showed that 120.72 million hectare of land in India are coming under degraded land. Okay, but if you see the more recent estimate given by the Space Application Center in 2021, that 97.85 million hectare, that is 29.77% of the Indian land, are coming under degraded land. So this information is very much useful for your ICAR JRF, SRF or ICAR level examination. This is the most recent estimate. If you see the other older lectures or other PPTs, you will find the older estimate, but that is not useful now for these days for exam purposes. So you see, this is exam for ICAR level examination. If you want to stay tuned to get such type of information from me, so please subscribe my channel, enjoy my video, and time to time I will upload this type of recent information for your exam purposes. Also try to concept the clear in my videos, so try to see my lectures very carefully. Now coming to what are the consequences if the soils will be degraded. See, soil productivity will be reduced, there will be poor nutrient availability to the crop, there will be less water use efficiency, crop yield will be reduced, and there is the very greatest challenge to our food security or nutritional security to us. So what happened? Need scientific soil management. What is that? Identification means identify your problem, reclamation, then try to reclaim or solve that problem, and that will ultimately promote sustainable crop production. Now we are coming classification of the problem soil. What type of problem? I have already told that based on major constraint, first thing we need to identify that constant. Okay, so based on major constraint, problems are classified into four major categories. See, soils with physical constant, soils with chemical constant, soil with biological constant, means biologically degraded soil, soil with nutritional constant. So one by one I will discuss. First one is the soil with physical constant. See, these have 7 types of physically problematic soil, you can say: slowly permeable soil, impermeable soil, surface crusting, surface hardpan, shallow soil, highly permeable soil, and that is heavy clay soil. One by one I will discuss. Let's come. Slowly permeable soil means here water is very slowly enter into the soil, that is less than 6 centimeter per day. That is, what will be the consequences? Water will stagnate in the soil, and ultimately when water will increase in the pore space, there will be less what we will call air in the pore space. If there is less air, that will cause pore aeration, and when there is little amount of air, root respiration will be affected, so it will promote pore suffocation, or root suffocation will be there, and there will be reduced microbial activity, because microbes also require oxygen, so there will be less amount of oxygen. And then you see second one is the impermeable soils. That is also that hardly allow any water to move into the soil. So rainwater accumulate, it will again promote such type of problem, water logging, there will be root suffocation, root diseases, oxygen deficiency, already I told. Then soil surface crusting. This is very important phenomena. In another one lecture, I will try to discuss detailed about soil surface crusting. What happened when crusting happened? The beating action of the raindrop causing the destruction of the aggregate of the soil. So when the soil aggregates broken down, soil particles become very fine, and that cause the clogging of the soil pores. When the pore space or water conducting pores will be clogged down, so what will happen? Water cannot penetrate, and there will be a formation of the thin layer on the soil surface. And when sun drying will happen, this thin layer will become very hard, that is called crust, and formation of such crust is known as the soil crusting. So what will be a poor seed germination? If there is a hard layer, seed cannot germinate, there will be less seedling emergence, that will affect the process of the infiltration will be reduced, the increased surface water runoff, so all this will happen. Next come to other type. Fourth one is the subsoil hardpan. There is a compact layer developed in the below surface due to use of heavy machinery. There will be the formation of subsoil layer. What will be the effect? Root growth will be affected, root elongation will be affected, ultimately nutrient uptake will be, and there will be drought susceptibility to the plants due to less water. Then shallow soils. From name itself you are understanding there is very little soil depth above the bedrock, means depth of soil horizon will be very less in case of shallow soil. What will be the problem? Again same like rooting depth will be limited, low soil moisture storage, and low nutrient reserve. Then coming to the sixth one, highly permeable soil. It's mainly you are from name understanding it happens in sandy soil. Why? Because sandy soils have higher amount of the macropores. Okay, due to macropores, that are water conducting pores, water easily move down through the soil. Okay, so water drain out easily, it will cause nutrient leaching, nutrients will dissolve in the water and get leached out from the soil. There will be low water holding capacity. Obviously the micropores are the water holding pores. So in sandy soil, where there is micropores, in clay soil there are micropores, sandy soil there are no micropores or so little micropore, and so it requires frequent irrigation. So you need to give irrigation frequently to meet up the water requirement of the crop. Heavy clay soil, so it contains very high amount of clay, you can say more than 40% of clay it contains. Okay, characteristic pore drainage, because it holds the water, it's sticky when it is wet, it becomes very hard when it is dry, and it is very difficult to tillage practices. Now coming to the soil with chemical constant. First one is this major chemically affected soils, you can say salt affected soil, then acid soil, acid sulphate soil, and calcareous soil. These all are important for your exam. I will tell you one by one. Salt affected soil means the soil which contain larger amount or appreciable amount of salt. And you can say when the exchangeable complex of the soil contains sodium, so those type of soil are known as salt affected soils, like saline soil, sodic soil, and saline sodic soil. These are major three categories of the salt affected soil. Characteristics: they cause osmotic stress, plant cannot absorb water, some iron will be present in toxic amount, that is called iron toxicity, poor seed germination will be affected, and there will be obviously nutrient imbalance, means either nutrient will be deficient or it may be present in toxic amount. Then soils with chemical constant, others one by one. Then acid soil. Acid soil means the soil having the pH less than 6.5, because neutral soil pH of the soil is 6.5 to 7.5. In strongly acid soil, pH is less than 5.5. What will be problem? Aluminium toxicity. This is a major problem often come in a JRF exam. What will be the problem in acid soil? That will cause the aluminium toxicity to the plants. There is manganese toxicity. There will be phosphorus fixation by the acidic cations like iron and aluminium will fix phosphorus. There will be calcium and magnesium. These are the basic cations. Acid soil where develop where rainfall is high. So it causes the leaching of the basic cations like calcium and magnesium, and it will promote their deficiency. Then acid sulfur. Again, this is very important in your exam. These contain pyrite. Pyrite means FeS2, iron sulfide. When it exposed to the air means oxygen, so it will get oxidized, FeS2 plus O2, it will convert to the sulfuric acid H2SO4. This is a very strong acid, so it will reduce the pH. If the fall below 4, and in exam it may come, what is the pH of your acid sulfate soil? That is 3.5. And these soils are very much toxic, and these are known as the cat clay of the soil. Again, this is important for your ICAR exam. Then calcareous soil, it may contain free calcium carbonate CaCO3 and pH above 7.5. This question also come in ICAR JRF, because what is the pH of calcareous soil? More than 7.5. Then problem, obviously some new micronutrient cations like zinc, iron, that will be deficient in calcareous soil. Again, phosphorus fixation, because above 7.5 there the abundance of calcium and magnesium. They will fix the phosphorus as a calcium phosphate or magnesium phosphate. Again, the availability of the phosphorus will reduce due to fixation. Now coming to the soils with biological constant, these are known as biologically degraded soil. These soils have very poor biological health. What will be the problem? Low soil organic carbon, low microbial population, reduced soil respiration will be affected, enzymatic activity will be reduced, like enzymatic activity like dehydrogenase activity, acid phosphatase activity, alkaline phosphatase activity, all will be reduced. Degraded soil biodiversity, that will also be affected, and it will cause the erosion of the soil. Then last one, soil with nutritional constant, because plant for the growth require nutrient. If this become imbalanced, it will create problem. Okay, so the imbalance means either the nutrient may be deficient or it may be toxic. Okay, see what will happen. That may common nutrient deficiency like major nutrient deficiency like nitrogen, phosphorus, potassium, secondary nutrient deficiency like sulfur deficiency, micronutrient deficiency like zinc, copper, iron, manganese deficiency, boron, molybdenum deficiency, and nutrient imbalances. Already I told you, see how nutrient imbalance occur in acid soil. Micronutrient cations like zinc, copper, iron, manganese, they present but in toxic amount. So that is not desirable, that is also imbalance. Okay, so that deficiency reduce crop growth. Even when irrigation and other management practices are optimum, but nutrients are the major limitation. So we need to careful about all these things. So this diagram is very important. I have taken from very recent paper published by Sharma and his co-worker in 2026, and this is very important for the ARS level examination, because in ARS you need to write minimum, or if you do it in diagrammatically, your marks will be enhanced. How? What types of degraded land present? Erosion prone land. This is mainly present in arid climate where the wind erosion is a dominant. Salinized sodic land, again it is a prominent dominant problem of arid and semi-arid climatic conditions, because their evapotranspiration is higher than precipitation. So salts will be coming from the downward through capillary action. It will be deposited on the soil surface and cause the salinization. Desertification affect land, again it's problem of desert or arid climate. polluted land due to pollution, and deforestation, degraded forest land. When we are causing the deforestation, that will ultimately affect or cause the land degradation. Mining activity also lead to the land degradation. Abandoned or degraded agricultural land like shifting cultivation, that also degrade our land. Landslide prone, the hilly area, that is landslide also reduce the productivity of the land. Urbanization, industrialization, that also cause the land degradation. And coastal area and wetlands, there are inundation of the sea water. Sea water, you all know, the salty water, okay, contain huge amount of salt, that will promote the salinization. So in this diagram I have shown what type of different types of degraded land present in India. So you try to write in this way in your exam. It's minimum information, means you have written minimum information but given expression of lot of information from this diagram. So try to be write information in this way in your exam. Okay, so we have coming in the final portion of our lecture, and I want to conclude my lecture with the quote of Franklin D. Roosevelt, who told, "The nation that destroys its soil destroys itself." Thank you, my dear friend.